Shall we talk about bone cells? Let's. Okay, bone cells. We start with what's called an osteogenic cell. Osteogenic cell. Osteogenic cells are stem cells. Remember what makes stem cells special? Stem cells can divide to make more of themselves, and they can divide to make other things as well. Embryonic stem cells can make anything. Adult stem cells normally can make more of themselves and just one or two other things. Osteogenic cells can divide to create a type of cell called an osteoblast. An osteoblast. As you may remember from Bio 156, blast cells are involved in the creation of tissues often. So an osteoblast cell then actually forms the matrix of the bone. Not talking about the Keanu Reeves matrix. Matrix, remember, connective tissue. Remember, you have to know your tissues. Connective tissue. In bone, it has a matrix of collagen fibers and then calcium and phosphate minerals that form a mineral called hydroxyapatite are deposited in that matrix. Osteoblasts make the matrix, all right, then later the minerals are deposited in. When an osteoblast matures, it turns into a cell called an osteocyte. Osteocyte is a mature bone cell, and your bone is full of osteocytes right now, okay? You have the other cells as well, but most of your bone cells now are osteocytes. They are mature bone cells living in your bone. Now, in contrast, there is a completely different kind of cell. This cell is called an osteoclast. Osteoclasts actually are formed by the merger of macrophages, a type of white blood cell. And remember what macrophages do? Macrophages eat things. Macro, big, phage, eat. Macrophage, big, eat. They're big cells that eat things. So osteoclasts are a completely different type of cell than this line right here. The osteogenics turn into the osteoblasts, turn into the osteocytes. Osteoclasts, totally different, opposite end of the galaxy. Now, osteoblasts, when they form bone, that process is called bone deposition. Bone deposition. Why? Because we are depositing things to make more bone. Bone deposition. In contrast, osteoclasts are involved in what's called bone resorption. Bone resorption means taking minerals back out of the bone. Bone deposition, put minerals into the bone. Bone resorption, take minerals back out of the bone. And in particular, we're going to focus on calcium. Remember I said the two minerals in bone are mostly phosphate and calcium. So when bone deposition takes place, all right, we have to pull calcium out of the blood to put it into the bone. So bone deposition, therefore, results in a drop in blood calcium. Blood calcium goes down. We are pulling calcium out of the blood to put it into the bone. In bone resorption, we're doing the opposite. We're pulling calcium out of the bone and putting it back into the blood. So what happens as a result of that? We raise blood calcium. Okay? Grok all of that together. Put it into your brain, cement it, burn it into your neurons, all right? 4 bone cells participate in 2 physiological processes, bone deposition versus bone resorption. Bone deposition will drop blood calcium because calcium is pulled out of the blood and put into the bone. Bone resorption raises blood calcium because calcium is pulled out of the bone and put into the blood. Now, what controls all of this? Who decides when what happens? What are the 2 control systems in the human body? Nervous and endocrine. And in this case, the endocrine system is incredibly important in controlling blood calcium. So let's take a look at 3 hormones that are involved in controlling these processes. use the rags I work on my car with. Double duty. Okay, let's look at 3 hormones. Let's look at PTH, Calcitriol, and Calcitonin. These are the 3 hormones that control calcium homeostasis. They control calcium levels in the blood. What does PTH do? PTH raises blood calcium. PTH again stands for parathyroid hormone. I guess maybe I can't say it again because I didn't say it the first time, didn't I? Okay, I'm saying it now. Rewind your brain. PTH, parathyroid hormone. Parathyroids, your thyroid gland is right here. Your Adam's apple is your thyroid cartilage. On the back side of your thyroid gland are parathyroid glands, and they make parathyroid hormone, PTH, parathyroid hormone. So parathyroid hormone raises blood calcium. How do you suppose it raises blood calcium? It stimulates a certain kind of cell to do that. What kind of cell do you suppose it stimulates? Yes. It stimulates osteoclasts that cause bone resorption. Okay? So, if you have low blood calcium, your body will release parathyroid hormone. That will stimulate the osteoclast to start pulling calcium out of your blood, bone resorption, out of your bone rather, bone resorption, and put it into your blood. Therefore, it raises blood calcium. Now, calcitriol does the same things, but it does one more thing. So I'm going to put "and" for calcitriol, and it increases, I'd like to buy a vowel, I'd like to solve the puzzle. It increases calcium absorption in the small intestine. So when you eat food, that food goes down your esophagus, into your stomach, into your small intestine. The small intestine is where we absorb nutrients into our blood. So calcitriol, by the way, has another name. Do you know the other name for calcitriol? Calcitriol is also called vitamin D. So calcitriol allows your body to better absorb calcium from your food into your blood. Isn't that great? Now, for example, little kids growing, making new bone, little kids should have a lot of calcium in their diet. What substance does mom naturally provide that's high in calcium? Yes, milk. And so milk is then high in calcium, the calcium is absorbed in. But you've got little kids, after they're done breastfeeding, now they have to get calcium some other way. So cow's milk, that's what typically used in this country. Little kids drink cow's milk. And to make sure that they can absorb the calcium from that cow's milk, the dairy industry puts what into most of the milk that you buy in the store? It's fortified with what? Vitamin D. Do you see why now? Do you see why most milk you buy in the store is fortified with vitamin D? It's so that the calcium in the milk can be absorbed better into your body with the help of the vitamin D, okay? So notice I put PTH and calcitriol in the same color because they both raise blood calcium. They do it by stimulating osteoclasts to do bone resorption, and vitamin D in particular also increases calcium absorption in the small intestine. Now, what does calcitonin do? Here's a cute little trick. Remember, calcitonin, bone in. Calcitonin, bone in. I had a girl in my class last semester named Kelsey, and we talked about this in class, and so we started calling her Calcitonin. So calcitonin lowers blood calcium. All right, so, oh, what the heck, I guess I'll try to stay somewhat color consistent here. So calcitonin lowers blood calcium. And why do you suppose calcitonin lowers blood calcium? Where do you suppose it's putting that calcium? Yeah, so it's stimulating osteoblasts. Osteoblasts to conduct bone deposition. Bone. I'd like to buy a vowel, an O. There we go. Bone deposition. We deposit into the bone. So bone deposition. So there you have it. Two hormones here increase blood calcium by stimulating osteoclast to do bone resorption and by increasing calcium absorption in the small intestine. Whereas calcitonin lowers blood calcium, it pulls calcium out of the blood, stimulates osteoblasts to put the calcium into the bone. Calcitonin, by the way, is only really active in children. By the time you're an adult, you don't have really any calcitonin activity in your body. So how can you either raise or lower your blood calcium? So PTH, we said, can raise blood calcium. If you don't have calcitonin active, how could you lower blood calcium? I want you to think about that. That's a little critical thinking puzzle. I know you can get there. Text or email me with any questions.